we're finally getting into the book this week. So I'm going to combine 1.1 and 1.2 from the book in these couple of videos. 1.1 and 1.2 both talk about transformations. This slide right here is one of the most important slides you'll kind of see all year. All right, this information transfers through to every function family that we will talk about eventually. We are going to focus on absolute value functions and quadratic functions. We have y equals a times the absolute value of x minus h plus k for the absolute value. And then we have the quadratic is y equals a times x minus h squared plus k. Notice these equations, functions are exactly the same, minus the fact that one has absolute value bars, one has a square on it. That's what makes it absolute value. That's what makes it quadratic. They each have a y, a, k, x, h, and k. All right, they each have those things. The underlying information affects the graph differently. The a value, if there's a negative out front, it flips it. That's all it does. All right, if it's negative, it flips it. If there's an actual number out front, it depends on what type of number it is. If it is a number between 0 and 1, typically a fraction, 1/2, 1/3, 3/4, and so on. There's a vertical shrink by a factor of whatever that number is, by a factor of a. Just the opposite, if you have a number bigger than 1, it's a vertical stretch. We'll see what they look like in class when we deal with that. H and K, H moves the units left or right. So anytime you have a number inside parentheses or absolute value bars or radicals later on, this H value shifts or makes a translation left or right a number of units. So if you see an x minus h, you're actually going to move right h units. Whatever that h value is, that's how many units you're going to move right. Now it's the opposite sign. Normally you see a negative, you think that you're moving in the left direction on a graph. You pull it out as the opposite sign. So just keep that in mind. So you're moving right when it's x minus h. When it's x plus h, you're moving left that number of units. All right, so inside the parentheses or inside the absolute value bars, that value, that sign is kind of going to lie to you. Now the k value, it is what you think. If it's a positive k value, you're moving up that number of units. If it's a negative k value, if it's a minus a k value, you're moving down that number of units. All right, so this slide right here holds the key to this, almost this entire chapter, for much of this chapter. All right, so just keep all that in mind. Everything we talk about today is going to involve this slide. So all I want you to do is describe the transformations for me. I'm going to give you a function, and we're just going to describe the transformations. So I just read it left to right like I read a book. I don't have any a value out front. It would be right here if there was one, but there's not. All right, inside here, it's x minus 4. X minus h is what we're dealing with here. It's minus 4, so we're actually moving right 4 units. And just put right 4, that's fine by me. Then afterwards, we have this plus 5 outside. Plus, we're moving in the upward direction, so we're going up 5 units. That's all I need for a description. Number 2, f of x equals 3 times the absolute value of x plus 2. This time we have a number out front. The number out front is 3. If we look back here, a value bigger than 1, we have a vertical stretch. I'm okay if you just tell me the fact that there is a stretch. I would prefer if you told me a little bit more and told me it was a stretch by a factor of 3. And then I move on to the inside. I have x plus 2. I'm moving the opposite direction as I did in number 1 there, so I'm moving left 2 units. And that's all I'm doing. Let's run through these last 3, just more examples. Now this one, I have a negative out front. If you recall from that last slide, a negative out front, all it does is flip it. That's all it does. So we go ahead, we just say it flips. That's it. Now, this -7 trips us up sometimes. It's -7 here at the end. It is not inside anything. It's not inside parentheses. It's not inside absolute value bars. So that means it's moving up or down. In this case, it's moving down 7. The left or right movement of the H value needs to be inside something, parentheses, absolute value bars, radicals eventually. It's got to be inside something. Number 4 here has got a little bit of everything. We got 1/3 out front. Just the opposite. If you look above at number 2, we had a 3 and that stretched it. We had a 1/3, so it's going to shrink it by 1/3. Move on. We got x minus 1. If you look at all your other stuff that we've talked about, inside x minus 1, we're moving right 1. And then last one here, we got a +9 outside the parentheses, so we're moving up 9. And that's all our transformations that are being made. Last one. This one's literally got a little bit of everything. So left to right. First thing I see is a negative. All that does is flips it. Next, I focus on 5/2. Now, careful here. I'm trying to trick you, and I'm doing it on purpose. 5/2 is a fraction. But that 5/2, that fraction is bigger than one whole value. So it's bigger than 1. So that actually is going to be a stretch by a factor of 5/2. So keep that in mind. Watch for something like that. Inside, it's a +4, so we're going left 4. It's a -1 here at the end, so we're going down 1. And there's our information, there's our transformations. All I want to do is describe the transformations. Next, I want to give some visuals on the same thing. I want you to describe the transformations of this graph. I'm giving you a hint. There's no stretching or shrinking in these, so there could be a flip, there's some left or right, and there's some up or down movement. So I ask what transformations were made on the parent function, the red solid line, to create the new blue dotted line function. All right, so the red is our original function here. What you need to pay attention to is the point called the vertex. You should know what the vertex is. That's what you're paying attention to see if it moved. We can obviously see that it got flipped. So we have that. Now, how did the vertex move? Well, we moved left 5 units. So we have that. And we also moved down 3 units. And there's our transformations that we made. There was a flip, we moved left 5 and down 3. We could use that information and write the equation if we wanted to, which we're going to do in the next video. Last one for good measure here. Number 7, this is an absolute value function. Same thing, we're going to focus on the vertex. There is no flip on this one, so there's that. Again, there's also no stretch or no shrink in these ones. So we're moving right 3, moving right 3, and we're moving down 4. And there's my transformations. That's all we got.